I received a homework question this weekend that I decided to make a video for because it was a more complicated question on solving trig equations where you need to use the identities to be able to solve them. So this is the question: 3 minus sine theta equals 6 cosine squared theta. If I'm trying to solve this algebraically, this is essentially like having a y and an x in the same equation. I can't solve two variables with one equation, so I need some way of turning either sine into cosine or cosine into sine. So I already have this Pythagorean equation: sine squared theta plus cosine squared theta equals 1. I can solve this for cosine. So cosine squared theta is equal to 1 minus sine squared theta. And then I can plug in this for what I have over here is cosine squared. This will give me an equation that has only sines in it. So moving back over here, I can replace the cosine with a sine. So I have 3 minus 3 sine theta is equal to 6 times 1 minus sine squared theta, using my Pythagorean identity. The next thing I want to do is distribute this 6 and then move everything over to the left. So I have 3 minus 3 sine theta is equal to 6 minus 6 sine squared theta. I'm going to subtract 6 from both sides, and I'm going to add 6 sine theta, sine squared theta, to both sides. These two numbers are constants and they'll work together, but these two are not like terms, and so I'll end up with both of these terms over here. So that will give me 6 sine squared theta minus 3 sine theta, and these two will end up with a negative 3 equals 0. Now, to be able to solve an equation like this, I either need to use my quadratic formula or I need to be able to factor it. The factoring will probably be the easier way to go, and I notice that I have a 6 and a 3 and a 3, and that gives me a GCF of 3 that I'll need to factor out before I try and factor this problem. So factoring out my GCF of 3, I have 3 times times 2 sine. 2 sine squared theta minus just sine theta and minus just 1. Close parentheses equals 0. That way if I put the 3 back in, I would get a 6 and a 3 and a 3. Alright, next I want to divide away this 3. I don't need it. When I divide away the 3, I end up with 2 sine squared theta minus sine theta minus 1 equals 0. And now I need to be able to factor this. I'm going to use what I call the superstar method of factoring, and if you're unfamiliar with this method of factoring, I've made a separate video on just how to use this method. Here I want to use a and c and b. So the top will be a times c, which is negative 2, and the bottom will be b, which is negative 1. I'm looking for two numbers that will multiply to give me negative 2 and add to give me negative 1, and I want to add in my leading coefficient so that I can deal with it while I'm factoring. So the leading coefficient goes up here, and here would be my two numbers that I want to multiply to negative 2 and add to negative 1. So negative 2 plus 1 would give me a negative 1 and multiply to give me negative 2. So here is negative 2, and over here I'd have a positive 1. So I'm going to deal with these two fractions that I've made. This fraction will reduce. So this is really 1 over 1. So when I factor this, I'll have a leading coefficient of 1 minus 1 and a leading coefficient of 2 plus 1. That would give me sine of theta minus 1 times 2 sine of theta plus 1 equals 0. I can then separate these two equations, set each equal to 0, and solve. Sine of theta minus 1 is equal to 0, or 2 sine of theta plus 1 is equal to 0. Squeeze that in. Here, I have sine of theta is equal to 1, or I would subtract 1 and then divide by 2. I have sine of theta is equal to negative 1. So now that I have these equations solved for just sine, I need to list all the angles theta for which either one of these would be true. So let's go over to my unit circle and figure out where these are. I need all the angles in which sine is 1 or sine is negative 1/2. So coming over to the unit circle, I have, remember it's, oops, need a different color other than white. Let's see. I have cosine, comma, sine. And I'm looking for where sine would be 1, or sine would be negative 1/2, here and here. So I have my solutions. They are right here. Pi over 2, 7 pi over 6, and 11 pi over 6. So I just need to go back to my solution set and write them in. I have pi over 2, comma 7 pi over 6, comma 11 pi over 6. So I will zoom out so that you can see the entire problem all together. This is the entire problem, including the scratch work. It's a longer problem because I needed the identities originally to be able to change it into just a sine or cosine problem. And again, if you're not sure how to do this part of the problem, I've made an entire separate video on just how to apply the superstarred method of factoring. All right, I hope this helps with your equation solving problems, and I will see you in class.